Hello, welcome everyone to the session. My name is Igor Shvets. I'm a CEO of Avantgarde 365, the consulting company on Dynamics product, Power Platform, and Azure. And I have a particular love for Azure Logic Apps. So what we're going to talk today is how to unleash the power of .NET C# in Azure Logic Apps now with extra Sizzle. So what's going to be an agenda for today? We're going to see the introduction of the use case. We're going to have a brief overview of what Azure Logic Apps are. We're going to take a look at the standard plan for the Logic Apps, the one that's necessary to run the inline C# code. We will see the C# inline code in Logic Apps. We will see the difference between Azure functions and C# inline code and the use cases. As always, we're going to look at advantages and disadvantages of C# inline code, and we'll have a demo and the conclusion. Going to the next slide. So we're going to look at the different use cases for the global event management and notification systems. So we're going to see C# use cases for managing multiple time zones and possibly custom reminders. We're going to see how to process large data set. We will see how to ensure secure data handling using encryptions. So overview of Logic Apps. Obviously, if you're all here, you should be aware what it is. So Azure Logic Apps is a cloud service that automates workflows across different apps and services. It integrates with the various connectors like Office 365, Azure services, and third-party APIs. Logic Apps can handle complex workflow with condition loops and error handling. And personally, I want to say that it's probably the best workflow engine in the world, used by many corporations, and we used it in many scenarios, and it was extremely robust and having like enormous customer satisfaction for using it. So in order to run C# and inline, it's very important to run it as a standard plan, right? The serverless will not work. So what's the difference? It's the execution environment. So it runs on a dedicated compute environment with improved performance. It has its cost efficiency. You pay for what you use with the consumption-based pricing. The flexibility, it supports custom connectors, inline codes, and other integration with Azure services. So how to leverage C# inline code? It allows custom logic using C# code and .NET directly within Logic Apps without external dependencies. So you can use the .NET libraries for complex operations like time zone conversion, encryption, advanced string manipulations, payload processing. Inline code executes within the Logic Apps workflow, reducing latency compared to external calls. So later in the presentation, we're going to see the pros and cons of using this approach, right? Like everything else in technology, it has its pros and cons that we're going to be looking in details. Okay, so you might ask yourself, but we already have something similar. We can run the C# code using Azure functions. So it's very reasonable to ask yourself, why would you run inline code versus Azure functions? So let's look at why you would use each one of them. So let's look at the execution. Azure functions runs as a separate services. The C# inline code executes within the Logic Apps workflow. Latency, you're going to have a slight overhead due to external service call in Azure Logic Apps. In C# inline code, low latency, executed inline. Scalability, it grows independently like a tree. And inline code is limited by the Logic App scale like a plant. The complexity, so Azure function, it's a Swiss Army knife, can handle complex tasks with different tools. Inline code, the recommendation would be a puzzle piece. It fits within embedded logics very neatly, right? A very important deployment. The deployment is like a satellite launch. It requires a separate mission control. So you need to hold your Azure function separately and handle it separately. The inline code, it's onboard tool, it's ready to go without extra steps. So all you need to do, just put it as a step in your Logic apps, and you call it a day. Security, it's obviously Azure Function. It's like a fortress. It's secured with the app service features. Uh, the inline code is protected within Logic Apps, right? So it's very important to look at the use case and see when and where you use it. We'll go for the next slide. So the advantages of C# inline code and why choose C# inline code. First, it's a simplified workflow. It's all in one scenario. It keeps everything within Logic Apps. No need for the separate Azure function. It's effortless management. Focus on building, not juggling multiple services. Also, what happens in the large corporations? You can have different teams responsible for the Azure function, right? So the advantage is you can handle more simple scenarios within your Logic Apps. Lower latency, so instant execution, run codes directly within Logic Apps, cutting out delays. It's fast and efficient, experience much quicker response time without the overhead of the external calls. The flexibility, it's dynamic operation. You can tackle complex logics and dynamic tasks, right? It's inside your Logic Apps. And obviously, the .NET power. You could leverage complex .NET libraries for advanced processing. Cost effective. It doesn't come with no extra costs, so you can avoid additional expenses. No need to spin separate Azure functions, even they're not expensive. It could be an issue, and it's one-stop processing. Everything happens in the Logic Apps, saving both time and money. Like everything in technology, or maybe even in life, everything comes with advantages and disadvantages. So the disadvantages, it's obviously limited scalability, the performance boundaries. So inline code is tied to the Logic App limits. It struggles with the high volume scenarios, and it's not for heavy lifting. It's best suited for simple and moderate tasks, not massive and scalable operations. Debugging complexity. Okay, it's much harder to troubleshoot. Inline code can be tricky to debug within the Logic Apps environment, right? You need to extract the codes, you need to pass separate payloads, so it's a little bit more complicated. Limited visibility, it's less straightforward than debugging separate Azure functions. The code maintenance, it's tangled logic, so the complex code embedded within the Logic Apps can become difficult to manage. And it's hard to untangle. Workflow might get messy, making updates and maintaining them. So it's really important for a good architect to see what kind of use cases that you will use for which scenarios. And we're going to see a couple of use cases that I think it's perfectly suited for the inline code. The execution limits, so timeouts and size caps, inline code may face execution timeouts and restriction on the code size. Environment constraints, you have to be mindful for the limits of the Logic App context. So to sum it up, our key takeaway, the C# inline code power and flexibility is direct integration, seamlessly handles complex logic without Azure Logic Apps. A versatile solution. It's perfect for tasks needing quick inline processing without external dependencies. It's ideal for low latency and simplicity. It's the best for scenarios where speed and straightforward workflows are essential. It has limited scalability, not best choice for high scale or highly complex operations. So Azure functions, scalable and modular, independent of Logic Apps, great for more scalable modular logic that needs to be managed separately, and handles complexity, better suited for larger, more intricate processes that requires dedicated resources. So how to choose the right tool? It's balance your need, assess your specific requirements and its performance and scalability, and pick the right solution for the job. Okay, so it's going to be a demo time. Right, so let me See here. So first, let's see how it's used in the real life. I apologize in advance if the code is a little bit if the code is a little bit small. So if necessary, we'll provide the source code as extra after the session. So there are three different logic apps that we're going to look today. One is going to be called test C sharp. It's something going to be extremely basic. So we're going to see how to code, how to call C sharp code within the logic apps using very basic scenario. So one case we're going to look is when the HTTP request is received. We have a very simple object with the first name, last name, and the date of birth. Okay. So what what the C sharp code can do, it's able to get information from the HTTP request and process it. So what we're going to do today is we're going to take a look at the code inputs. It gets the trigger inputs. It gets the data from the JSON, first name, last name, date of birth. It can easily do very simple calculation like calculate the age based on that date of birth. It can concatenate full first and last name to make it a full name. It log information to the application insights and send you a message. Obviously, the beauty of using C sharp code is you have exception handling and you have the error, a very detailed log. Another beauty of it, you can keep your code separate. And as you see here, you're able to have a separate function that will calculate your age based on that date of birth that's been passed. So you can compartmentalize your logic, and then as a result, it will assemble the message that you will display on the screen. So let's see. So let's see what it does. So if I copy a payload, go here, C sharp, and I run it with a payload. Paste. So we have the first name, the last name, the date of birth. I click on play, and it will tell me, welcome, Julie Alcaz, you're 36-year-old. The city you provided is Toronto in Canada. So let's look at the data further. So here we're able to process and calculate the date of birth. So another thing that we can see is if we initialize a variable and assign the value to it, and if we call and we set a variable by assigning a value with the city of Toronto, we have another C sharp script that will at this time not read the data from the HTTP, but also from the variable, right? So you can use it in the different places in your script, and this can pull the data and execute it. So if you look at the C sharp code, you have your using statements, you calling the trigger outputs, and you have your action outputs. So by getting the action outputs, you calling the set variable action that it's right before it. You get the body of this. You get the body of this of the action output. You initialize the country. You do your validation just to make sure your value is there. Check for nulls, and you say if the city is equal to Toronto, then you will say you're in Canada, and else you're going to say it's in the US. You can log the rest of the information and return your results. So it's very simple use case. So here, what we see is that we can use the C sharp code from the HTTP directly. Probably in the real life, you would use compose and parse it. But just to let you know that it could be used in multiple environments, or you can read it from the variable directly. So if we run it again, Mhm. Okay, 1 second. If you run it again with payload, it will show us that the Julia is from Toronto. So if you refresh, like everything else in the Logic apps, you can look at the execution details, and you can see that the payload you can see the payload you received, and you can see the details behind the execute C# script. So you have the name of the code, you see the output and extra data. So it handles just like any other Logic app action. So same for the seeding. So you have hello, the seeding you provided is this, and it's based on the value of the variable that you have here. Execute C#, and at the end you'll send the response that will concatenate the data and output the value. So this is the most basic example, and we have two more that is slightly more complicated. If we go here, there is one example that's called encryption. So here we better start with the actual execution. So since we're talking about event management, I want to be able to encrypt in my payload my name. So let's say I paste the payload, and the name that I wanted to encrypt is my name here. So let me just maybe it's easier if I just remove myself. It's going to be the encrypted name. This is the one that I want to remove, right? So if I run the execution, just remember this name. I run the execution, and I have my name encrypted based on the JSON payload. So how this is done using this is done in the Logic app using inline code. So let's look at the designer. So just like before, it will get the request body and the JSON schema. So we have our parameters that we're going to put in, and this is where it becomes more interesting. You can, as you can see, you can put the pretty complex code into there. Based on the trigger, we're getting the trigger results. We're getting the body. We're making sure the body is not null. We're getting the name of the attendee. Obviously throwing the exception if we cannot find it, and we just give an encryption key. Give a very simple encryption key. It could be much more complex, but for the simplicity's sake, this is what we show. And you call the method to encrypt the string using attendee name and encryption and the encryption key. So we look at we replace the encrypted name in the payload, log the encryption process, and show the results. And the beauty here that you can have the whole pretty complex method for the encryption of the string. So you get a plain text and you get a string. You obviously verify for null or empty, and you're going to use your algorithm to iterate to replace the string with the encoded value. So if we obviously this is an example. This is a simple example. You will not going to be likely you're not going to be putting the encryption key in the open text in your C# in your C# code. The idea here is just to show what is doable, right? And in the real life, you will be hiding it and not exposing it like this. You will be injecting it differently. But the idea here is to show you that what is doable using the C# code and the inline function. So after this, we're going to process the data from our execution of our C#, and we will expose the response using a encrypted string. So if you look at the execution, we receive the value, we receive the payload with the encrypted name here. The properties. We have the body of the message where the name is encrypted. We're passed a JSON based on this payload, and it gives us the formatted text that we're ready to use in our response, and paste it in our response. And our response is the encrypted name. So you can store it anywhere in after and use it for your system. You can use another method to decrypt it if necessary. We're gonna have one more example, and I find this is probably going to be used the most. It's validate complex payload scenarios. So often, what used to happen in our organization, we had trouble validating a payload that was dynamic. And there are different methods for this, but I find that this inline C# code is going to be it's going to be absolutely great for it. So the example we're going to see here is we're going to have a very, very complex, well, not very complex, but relatively complex JSON payload. An idea for it is you have different sessions, you have different emails, you have different start times, you have different contacts, they can have different emails, etc. So idea is I want to get this payload, and I want to make sure that all the emails are properly formatted. Okay, and if they're not properly formatted, I want to get a notification. So right now we see that all the emails are properly formatted. So if I run the execution, I say all emails are valid. So I'll close it. So let's run it again. Let's go here. Let's find one email, and let's just remove the com. Very realistic scenario. We'll run it. It will tell me that there is invalid email format for the Emily Taylor. Okay, so situation like this happens very, very often, and I find that using the inline C# code it's an amazing tool for this use case. So let's see. Let's look behind the scenes. So let me just maybe increase it a little bit. So just like everything else, we have our JSON schema. We have, as you can see, fairly complex schema. And we have our C# code. Okay. So what do we have? So we have our trigger inputs. We extract the full JSON body. We have the list of, we're creating a list of all the invalid emails. After what we're going to do, we're going to validate email in the event organizer contacts. So we're going to iterate through the structure. We're going to look at all the contacts email, and if any of the emails are invalid, we're going to add it to the list. Also, for the other nodes, we can validate the emails in the sponsor contacts. We can validate email in attendees. We can validate emails in the session speakers. And later, what we're going to do, we can return results based on validation. So if there is count of invalid emails is about 0, then it's going to return us a new object stating that the emails are invalid. Or else it's going to return the valid object. So also you can use, again, non-trivial C# logic using the regular expressions to make sure if the email is valid or not, right? If something is not correct, you will catch an exception. So I think in about 110 lines of codes, we're able to get a non-trivial payload and validate multiple nodes against the regex to make sure that our emails are valid. So the same things obviously you can do for phone numbers, you can do maybe for addresses, you can do any kinds of validation. So, and as you can see, it also runs pretty quickly, and you do not need to worry about anything. Just put your inline code, parse the information, and the magic will happen. Okay, so if we look at the execution, just like before. So when we have HTTP is when HTTP is received, we're getting the headers and the body. So we take all this information, we put it in our C# code. We have just like everything else before, we have the inputs and the outputs. It tells us that the email is invalid, and we have the property and the session. And once this is done, we have the response for our HTTP call. So as you can see here, we've seen three different examples. First is our test C#. Very simple example that you can use it for very simple use cases, like get data from HTTP, calculate the age, and run very simple conditional statements based on a variable. In the logic app number 2, for the encryption, we've seen that we can take a string and we can encrypt the string using our encryption methods that exist in C# and .NET. And the last but not least, we've seen how to validate complex JSON payload to make sure the email is correct. Now, obviously, it can get much more complex. There are other fields you can validate. You can also validate a structure of your JSON payload. Let's say if you give yourself a very permissive schema, you can use C# to validate, to give it extra level of validation. And you can use a conditional treatment based on this, based on the results of the schema that you have. So this is what I had to show for today. Those are our 3 samples. I would like to thank organizers for the opportunity to present, and wish everybody a great day or evening or morning. Thank you.